Hi, hello and welcome to lesson 6.7, interior and exterior angles of polygons today. So we're going to start with going back to angles in polygons. So triangle is a three-sided polygon and we know that the sum of the angles is 180 degrees. So we're going to go on to some more polygons. We learned about quadrilaterals the past week and we know that the sum of theirs is 360. Right? A pentagon has 5 sides, right? And if a triangle has 180 and then a quadrilateral has 360, we can take a guess that if we add another 180 to 360, we end up with 540 degrees. See if you can figure out then what a hexagon and an octagon is going to have. Oh, I keep hitting the wrong button. All right, I hope you thought that a hexagon has 540 plus another 180, which will be, I forgot, 720. And an octagon has 8 sides, so we have to add 180 plus another 180 to it. We get 1080 for our octagon. So an octagon has 1080 degrees. Right, so in your book you have this nice table, so I'm going to fill in the first column, number of sides, and then you can go ahead and finish in filling in the rest once I go through the first couple. So an octagon, we probably know triangle, quadrilateral, pentagon, hexagon, heptagon, octagon. A nonagon is 9, a decagon is 10, and be careful, a dodecagon does not, it's not going in order all the time. Okay, a dodecagon actually has 12 sides. And an icosagon has 20, and then an n-gon means that's just going to have n sides. So no matter what we have, we're going to do it in terms of n. So we know that the triangle's sum of interior angles is 180. And then it's what's the measure of each angle? Well, it's an equilateral triangle. We could divide 180 by 3, we get 60. And each exterior angle, we know that the interior and the exterior are going to be supplementary, so 180 minus our 60 is going to give us 120 degrees. Right? Quadrilateral adds up to 360. We just learned that in the previous one. Each interior angle in a regular, should write a regular up here, which means a regular quadrilateral. Okay? So that's going to be 360 divided by 4, 90 degrees. And so again, they have to be supplementary, so the exterior angle has to be 90. Oops. So see if you can figure out the rest of the table. All right, so I hope you got this for the table. We'll talk about them. It takes me a while to write, so we did the quadrilateral, so the pentagon, you've got 540. I hope you got the sum of the interior angles, all right? So we just keep adding 180 until we get to decagon, though, because remember, dodecagon has 12, so we have to add 180 twice, all right? And then we need to figure out what the pattern is for the sum of the interior angles, right? So if you look, a triangle has 3 sides, and the interior angles sum to 180. So we have 3 sides, 180, okay? Next we have a quadrilateral that has 4 sides, and it has 2 180s in it because it adds to 360. Pentagon has 5 sides, and we have 3 180s. So I hope you're starting to see the pattern that we take 180, and then if we have a triangle with 3 sides and it only has 1 180, that would be n minus 2. So 3 minus 2 gives us 1. 4 minus 2 gives us 180 times 2, which gives us a 360. 5 minus 2 gives us 3. 3 times 180 gives us 540, and we could do that all the way down to 20. So how you get a 20 is you do 20 minus 2, or subtract 2, which is 18. Multiply by 180, you should get 3,240 for its interior angles. Now let's look at the sum of each, or the each interior angle measure. So this is again for regular polygons. So equilateral triangle 60, square 90. Okay, a pentagon, you do 540 divided by the total number of sides, which is 60, or that also if the number of sides is the same as the number of the angles. So 540 divide 5 is the number of angles. You get 108, 720 divide 6, and so forth, all the way down. So we need to come up with a pattern, and that is we take our total, the sum, and the formula for sum is 180 times n minus 2, and we divide it by, whoops, let me rewrite that. We divide it by the number of angles or sides we have. So 180 times n minus 2 divided by the number of sides. That will give us our angles. Okay. And to get each exterior angle, we just think, well, an exterior and interior angle have to add to 180, so we got 120 for the triangle. 90 plus 90 is 180. 180 minus subtract 108, 72, and so on all the way down. So the rule for this one we could say is we take each interior, or we take our total of the interior and exterior, which is always 180, and we subtract the interior angle. And the equation for the interior angle is right here. So I do 180 subtract 180 times n minus 2 all over n. Okay, now there's going to be a simpler formula. Okay, because let's look, I'm going to flip to a new slide real quick. I'm going to look and see, let's say we have a small triangle here. Oops. Okay, I've got my pictures drawn, oh, except one picture got messed up. Hold on one second. So I have a triangle and a pentagon here, and we can see its interior and exterior angles. And so what we're looking at for a simpler method is to find out the exterior angles. Okay, so if I look at this triangle, and I draw, let's say, we know that this angle is 120. We know that this angle is 120, and this angle is 120. We get a total of 360. Okay? In the pentagon now, we know that this is 72, this is 72, this is 72, 72, 72, and we still get a total of 360. So you can visually see how it creates a circle here. And a circle has degrees 360. So if we go back to this, the sum of each interior angle, or I mean each interior angle and each exterior angle, we have a sum of the interior angles, but we don't have a sum of the exterior angles. So the sum of the exterior angles is always going to be 360. And how you could do that is say, well, I have 3 sides times each exterior angle, 120, gives me 360. 4 sides times each exterior angle, which is 90, gives me 360. And you could do that for each one. So for hexagon, 6 times 60, well, that gives me 360. So the sum of all the angles is 360. So there's an easier way to figure out what the exterior angle is. If all of the exterior angles sum to 360, I just have to take 360 and divide it by the number of sides, and I'll get the measure of each exterior angle. And the same goes for the interior angle then. If exterior angles have that measure, then we could take 180, subtract our exterior angle, and we would get another formula for our interior angle. So if you look here, we have two formulas. We have 180 subtract n minus 2 over n for the interior, and we have 180 subtract 360 over n. This one's a little easier because there's only one n, and this one is a little easier for the exterior because we don't have this big long mess up here. Right, so just remember that all exterior angles of a regular polygon sum to 360. So now we're going to start with some problems. Okay, so it says use the equation to find the sum of the measure of the interior angles of a polygon. So the sum of the interior angles is always, remember, 180 times n minus 2. So using that formula, I get 180 subtract 180 times 2 less than its sides, so I get 180 times 20. And my answer is 3,600. So the interior angles have to be summed to 3,600. And now it says if we have a polygon that's equal angular, meaning it has to be a regular polygon, they want us to find the measure of each angle. So if you recall, we take 3,000, the total, and divide it by the number of sides. In this case, we have 22. And we get an angle measure of 163.64. Oopsie. Let's erase that 6 that's way down here. 163.64. Okay. Another example, I want you to look at this one and see if you can figure out the measure of the interior angle and the exterior angles. Right, you have that chart now that you filled out that you could use and see that it's a pentagon, so this is 108 and the exterior then is 72. Okay, but on a test you wouldn't have that, so it's also good to note the formula 180 times n minus 2 divide n. Okay, so the total is 540 for a pentagon. Divided by 5, we get 108. And for the exterior, we can use the formula 360 divide n, and we should get 360 divided by 5, and we get 72. Right, so we could use the formula, or again on your homework you can use a chart. Alright, I want you to pause this example now. It says the interior angle of a regular polygon is 162 degrees. Find the number of sides. So there's going to be two ways to do this. I'm going to draw a line right down the middle. And that wasn't a very straight line. Let's try again. Draw a line right down the middle. And so one formula we know is we have 180 times n minus 2. That's my total of the angles, and I divide by the number of sides to get what each interior angle equals. So in this case, the interior angle equals 162. So let's go through this method first. First, I want to get rid of that fraction, so I'm going to multiply by n on both sides. So I'm left with 180 times n minus 2 equals 162n. I'm going to distribute now. So I get 180 n minus 360 equals 162n, and then I need to combine my n's on one side. So I'm going to subtract 162n from both sides. And I'm also at the same time going to add 360 because I know I need to get my numbers on one side. So this is gone, this is gone. So I'm left with 18n equals 360, divide by 18. N equals 20 sides. Right? So that's using the original formula I came up with. There's also, if we know that the interior angle is 162, can we find the exterior? Remember, exterior and interior angles are supplementary, so that means the exterior angle has to equal 18. Now recall from the previous page, the exterior angles, to find them, the easiest formula we found was 360 divided by n. Because always the exterior angles add to 360. If I divide by the number of angles or sides there are, that will give me each angle. So that has to equal 18. This looks like it's way easier to solve. If we put a 1 under the 18, we can cross multiply. I get 18n equals 360. Okay, divide by 18. In 2 steps, I got the same answer I did on the other side. So 20 sides for this one. Okay, next we're going to look at this one. And this one goes back to the same thing, 360 over n, because it talks about each exterior angle. So to get an exterior angle, we do 360 divide n. So see if you can figure out the number of sides for this polygon. All right, I hope you figured out the formula should be 360 over n equals 14.4. Again, it's same as before. Cross multiply. I get 360 equals 14.4n. Divide by 14.4. All right, so 360, and I get n equals 25 sides. All right, so I hope that one was pretty straightforward based on the last one. So always it's easier to use the exterior formula than the interior. And our last example is one that talks about a pentagon that has a ratio of its angles. It has 1 to 1, 1 to 2, 2 to 2, and 2 to 4. So what your first step is whenever you have a problem is to draw a picture. If I can draw a picture. I'm just going to use this segment tool because it's a little easier for me. Alright, so there's a better picture of my pentagon. It's not quite perfect, but it's better. Okay, so we know that there's 2 angles that have a ratio of 1, so we're going to call those 1x. We're going to call this one 1x. 2 angles, a ratio of 2. The biggest angle is 4, so total I have a 1, 1, 2, 2, 4, which is what my ratios are. Okay, and remember, a pentagon's total angles is 540 degrees. So if I were to add all these up, if I add them all up, I should get an equation. So see if you can solve this and tell me what you get. So I get 10x equals 540. X equals 54. So that means x equals 54. So if I go back to my picture, that means two of the angles here, though just the one x's equal 54. Two x's equal 108. So these two angles equal 108. And last, the other one is 216. Right? So I hope this helps you with your homework. I apologize for some of the errors. Made it through. Your homework is 6-7, numbers 1 through 10.